to my next one, gateway aggregation. Yeah, in this scenario, so what happens is, application can call, let's say there's an application is calling service one, service two, service three, and sending requests to, all of these services. So instead of application sending three requests, it can send only one request, and the gateway will handle segregation of the request and send individually to service one, service two, and service three. When they receive the result from there, it will basically bring together everything and return the message back to application. So that's the gateway aggregation. Gateway offloading is very basically the uh, common services or common functionality. Let me read through the definition. Offload shared or specialized service functionality to a gateway proxy. This pattern can simplify application development by moving shared service functionality such as use of SSL certificates or other parts of the application into the gateway, like logging and all those things, error handling kind of thing. The common part would be certificate verification or security authentication. Would be instead of having all those common thing, the cross services, cross-cutting services, instead of having in every service or every application, we can have those things as a common and can be shared across services. So there are many benefits of doing that. It's easy to deploy. You don't have to worry about those things because it's already there and managed by third party or managed independently. That helps in doing that, and it will basically reduce the efforts as well. Pipes and filters decompose a task that perform complex processing into series of separate elements that can be reused. Doing so can improve performance, scalability, reusability of initial steps by allowing task elements that perform the processing to be deployed and scaled independently. Pipes and filters pattern supports a high level of modularity. So basically, it's just saying it's bigger task divided into small tasks. That's all it's saying. Okay, priority queue. Um, the priority queue pattern enables a workload to process high priority tasks more quickly than lower priority tasks. So yeah, basically, you just put the priority on the task and it will be handled accordingly. Yeah, or you can have a different queues. So you can have high priority queue and then low priority queues. Yeah, I mean, similar way. Yeah, I mean, you can basically have multiple queues in a bus, or you can have separate bus. Pub and sub is very common. You have seen it. So for example, in integration, we can have Azure topics, and various subscribe to those topics and as per their need. And whenever message arrives, basically they can read the message from there and process it. In this scenario, the publisher is not worried about the subscriber received or not. It just publishes the messages, and subscriber is responsible to receive it and to process it. Queue-based load leveling, rate limiting, and throttling. So queue-based load leveling is when I have seen congestion in application. So application X is calling application Y, and the number of messages coming are high in amount, and it can block and overwhelm the system. So in order to reduce that challenge or reduce the uh, number of processing, number of message processing, we can have a queue. So we can dump all the messages into queue and let the application process as per its own time frame. Now, that's one thing. Now, if for example, we are using APIM and it has external interface to external third-party systems, so it is possible that they can send massive amount of information or massive number of calls they can make to stop that thing happening. There are two ways you can do it. You can rate limit, so you can tell, okay, for X customer can make X number of or Y number of calls per hour, and if they make it can be throttled. Um, so that can be done in APM easily. So that's why APM is a very I mean it's a very good gateway. It can do many things. So we must use APIM when we, especially when we interacting with external parties. So we have more control over and we are hiding our APIs from external parties, and we can control how they can use our APIs. So yeah, we can do those things there as well. Retry is very common. I mean, if you have connection back, so let's say you have access calling service Y and Y is down, and we have APM in between, so we can have retry those services. Now, retry has a problem as well, because if you do not have circuit breaker, then it will keep on trying. So we need to have some mechanism that after X number of tries, it should not try again until unless, the services are up. So I have seen that many times that, if there is no circuit breaker, I have seen messages lost, and I have seen systems overwhelmed because number of calls coming through from the client, and system is not able to cope with it, and it takes longer to recover actually if messages keep on coming. So the best way is to, like discussed earlier, when message comes through, and we would check, if it's working, if not working, and we try a number of times. If that fails, then we can open the connection, and then all messages goes into the service bus, and we have Azure function to process them and send and also notify the support team. All right, so let's move on to next one. Scheduler agent supervisor. So it's a coordinate a set of distributed actions as a single operation. If any of the actions fail, try to handle failure transparently, or else undo the work that was performed so the entire operation succeeds or fails as a whole. Yeah, I mean, this can add resiliency to a distributed system by enabling it to recover a retry action that failed due to a transient exception. I will cover this one in some other video about how to actually write this. I need some more time on that. So I'll invest more time in the next video, and I'll do separately. Now this is a strangler fig. It is more important when we are migrating legacy system to cloud, and it is possible that we can't migrate all systems in one go. So it is possible that some services, some calls we have to make to our on-premises system, and some services we have to make to our cloud system. So what we can do is we can use Strangler Fig. We can use APIM, and the client will make a request to APIM, and APIM will decide which call has to go to on-premises system and which has to go to cloud. Now, to connect to on-premises system, we need to make sure that we have a VPN connection or other express route, and then we need other things as well. So we need to make sure that the setup is there in order to access the on-premises system. Otherwise, it will not work. All right. So yeah, so that's a strangler fig. It's very easy. It's not very difficult. You just need to set up things properly. Now, the takeaway from this one is to ensure resilience and reliability in every solution. Uh, Use patterns as per need. Need to think about anti-patterns as well. Continuously review and improve design. So we have to go in iterations. We have to test our system, and we need to improve our design. So design is not just a one-time thing. It's a like a improving all the every time we go through system. We find problems, we look into design, we improve it, and we keep on doing until the point we have improved version of it. All right, thank you very much for listening, and I hope it might be helpful. And I'll produce more videos so I can help in integration side in Azure and other systems. Thank you.